Thank you for your interest in Complete Streets. The Community Traffic Safety Program in Northeast Florida is committed to education, outreach, and the Target Zero goal of reducing serious injuries and deaths on our roadways. This presentation will show why complete streets are important for safety and mobility and present an overview of the Florida Department of Transportation's Complete Streets policy and design guidance. We'll showcase complete street strategies and some real-world project examples in Northeast Florida, which help work towards zero fatalities on our local roadways. Let's discuss why complete streets are important for both safety and mobility. Because most of Florida's population growth and development occurred in the age of the automobile, our transportation system can be challenging to non-motorized road users, pedestrians, and cyclists. After making some progress through the 90s and early 2000s, pedestrian fatalities have been on the rise for the last decade. Nationally, 76% of fatal pedestrian crashes occur at night, and nearly half involve alcohol. The overall pedestrian fatality rate for men is about 2.5 times greater than for women. The highest fatality rates overall are among adults aged 55 to 64. When a fatal pedestrian crash occurs, the driver leaves the scene about 20% of the time. Nationally, bicycle crashes follow many of the same patterns as pedestrian crashes, with nearly half of fatal bike crashes occurring at night, and 86% involving male cyclists. In 2019, the last year for which national data has been analyzed, Florida had the highest number of bicycle fatalities of any state, and among the highest ratios of bike fatalities compared to all traffic deaths. Pedestrian crashes account for approximately 20% of the fatal crashes in the 18 counties comprising District 2. The four most urban counties, Alachua, Clay, Duval, and St. Johns, account for nearly 3/4 of all fatal pedestrian crashes and approximately 80% of pedestrian crashes overall. Similar to national statistics, 77% of fatal pedestrian crashes occur at night, compared with just 54% of all fatal crashes. While less than half of all pedestrian crashes occur along the state highway system, over 70% of fatal crashes occur along state highways. This is because state roads generally operate at higher speeds, carry large volumes of motor vehicle traffic, and are often flanked by land uses that attract pedestrians and cyclists. Similar to pedestrian crashes, bicycle crashes are concentrated within District 2's most urban counties, with 3 counties, Alachua, Duval, and St. Johns, accounting for 73% of fatal bike crashes and 84% of all bike crashes. Approximately half of the fatal bike crashes occur at night, which is similar to the nighttime percentage for all fatal crashes. Nonetheless, this points to the importance of roadway lighting, proper bike lights, and retro-reflective clothing as mitigating measures for bicycle crashes. The percentage of bicycle crashes occurring along state-maintained highways is nearly identical to that of pedestrian crashes, 42%. However, bicyclist fatalities are more evenly distributed between the state and locally maintained roadway facilities. Let's talk about FDOT policy and how they've responded to these safety challenges to move towards safer, more complete streets. Recognizing these challenges, the FDOT Complete Streets policy was officially adopted in 2014. The approach for the department is to consider all users of all ages and abilities and how it plans, designs, builds, and operates its transportation system. Complete streets mean roads that are designed not only for passenger cars and trucks, but also for transit riders, pedestrians, and cyclists. The Complete Streets policy called for broad changes throughout the department to revise manuals, guidelines, and standards, effectively changing how FDOT does business. The policy also explicitly states that complete streets are meant to promote safety, quality of life, and economic development, all goals of local communities. Lastly, the policy stresses a system of complete streets. Not every street will be the same, and instead, the idea is to build the right street in the right place and have each street support a complete network of transportation infrastructure for all modes. One important way complete streets are implemented is through context classification. The context classification system broadly identifies the various built environments existing in Florida, based on the general characteristics of the land use, development patterns, and roadway connectivity along a state roadway. These attributes provide cues as to the types of uses that will likely utilize the roadway, which in turn is used to make decisions about roadway design parameters. The next few slides provide an overview of each roadway context class. As shown in this Nassau County example, the natural context class applies to lands preserved in a natural or wilderness condition, including lands unsuitable for settlement due to natural conditions. Roadways in the rural context classification are found in sparsely settled areas, which may include agricultural land, woodland, and wetlands. The buildings surrounding the roadway in this context are generally 1- or 2-story agricultural or single-family residential that are detached from the road. Rural roadways have an allowable design speed of 55 to 70 miles per hour. These roads are considered high speed, which must be taken into consideration when figuring out which complete street elements can be incorporated. Roadways in the rural town context classification are located where small concentrations of developed areas are immediately surrounded by rural and natural areas. This includes many historic towns in rural parts of the state. Rural town roadways have an allowable design speed of 25 to 45 miles per hour, which means measures must be taken to slow traffic in advance of entering the town. Thoroughfares in the suburban residential context are areas with mostly residential uses within large blocks and a disconnected, sparse major roadway network. Suburban residential roadways are common throughout Florida and have an allowable design speed of 35 to 55 miles per hour. Roadways in the suburban commercial context classification are similar to suburban residential roadways but are fronted mostly by non-residential uses, with large building footprints and large parking lots. Buildings are within large blocks and a disconnected or sparse roadway network. Suburban commercial roadways have an allowable design speed of 35 to 55 miles per hour. These roadways are often problematic from a safety perspective for both motorists and non-motorized road users. Roadways in the urban general C4 context classification reside in areas with a mix of uses set within small blocks with a well-connected roadway network. Often these areas were developed prior to 1950 with residential streets connecting neighborhoods along the corridor or behind the uses fronting the roadway. Urban general roadways have an allowable design speed of 30 to 45 miles per hour. Urban center roadways are typically concentrated around a few blocks and identified as part of a civic or economic center of a community with a well-connected grid network. The roadways in urban centers have an allowable design speed of 25 to 35 miles per hour, reflecting short blocks, more intense land uses, and greater demand for non-motorized mobility. Urban cores are the areas with the highest densities and building heights within large urbanized areas. Buildings have mixed uses and are built up close to roadways with a well-connected grid network. Urban core roadways have allowable design speeds of 25 to 35 miles per hour, again based on a higher prioritization of non-motorized trips. Limited access roadways can pass through any of the other context classes and are, by design, separated from the rest of the roadway network except at defined interchange locations. Having established a complete streets policy and context classification system, FDOT developed a new design manual in 2018 to link roadway design criteria with a roadway's context classification. Among other things, the FDM establishes guidance for sidewalk width, appropriate bicycle facility type, lane width, and speed limits. Roadway speed limits are primarily derived from the physical characteristic of a road and drivers' normative response to these design cues. In other words, most drivers base their speed on what feels right for the road, and posting a different speed limit without changing the design of the roadway is unlikely to dramatically change drivers' operating speeds without massive traffic enforcement. The FDM acknowledges this chicken and egg relationship, but introduces a new concept to help trigger design interventions over time to achieve more appropriate operating speeds for each context area. This is referred to as a roadway's target speed and is based on a range of factors, foremost of which is to optimize safety. Once a target speed has been established, various design strategies can be employed to modify the roadway's design so that drivers adjust their behavior and begin operating at safer speeds. Some of these speed management strategies can be implemented as low-cost improvements done with roadway resurfacing projects. whereas others require more substantial reconstruction of a roadway and may require time to plan for, design, and finance. Moving on from FDOT's Complete Streets policy, context classification, and design manuals, let's talk now about some examples of strategies to make roadways safer and more complete for all users. These examples show the provision of bike lanes along a roadway and shared lane arrows, or sharrows, along a lower speed roadway to provide better accommodation for bicyclists. High-emphasis crosswalk markings can improve pedestrians' ability to safely cross the street, and where conditions warrant, mid-block crosswalks may be installed, sometimes used with supplemental warning devices to help ensure drivers stop for the crosswalk. When crosswalks are installed at unsignalized locations on higher speed, busier roadways, it's important to provide supplemental warning devices to raise driver awareness and compliance. Pedestrian hybrid beacons require traffic to come to a full stop using an overhead solid red beacon light and then allow traffic to proceed when clear with a flashing red beacon. In this way, they cause less delay to traffic than a conventional signal, but nonetheless provide a high compliance rate for pedestrians. Rectangular, rapid flashing beacons use a wig-wag strobe effect, which can supplement pedestal-mounted beacons with an overhead element on particularly busy roads. As development continues to grow along rural highways, it is often necessary to construct sidewalks to safely address increased pedestrian demand. Where feasible, shared-use paths may be constructed instead to serve both walkers and cyclists. Curb extensions and street trees are additional strategies to enhance pedestrian safety and calm traffic. The cost of implementing these depends greatly on drainage and utility considerations, but where feasible, they help to create a more welcoming environment for pedestrians. Like curb extensions and street trees, raised medians can both reduce traffic speeds by offering drivers a sense of enclosure and serve to shorten and simplify pedestrian roadway crossings. Roundabouts are a proven safety countermeasure for all users and are particularly effective at the junction of two-lane roadways when a simple, single-lane roundabout can usually accommodate the traffic demand. Well-designed roundabouts work by slowing approaching traffic so that if a crash occurs, it will be a lower-energy event, more likely to result in a fender bender rather than a substantial bodily injury. Along lower-speed roads with high pedestrian volumes, features like speed tables and raised crosswalks are important parts of the overall speed management toolkit. These measures use vertical deflection to force motorists to slow down in order to maintain an acceptable level of comfort. Typically, vertical deflection strategies would not be used on the state highway system, where they would be contraindicated by higher target speeds and volumes. But they could be used in limited circumstances, such as within channelized right turn lanes. When planning speed management strategies with vertical or horizontal deflections, it's important to coordinate with EMS and transit to help avoid unintended adverse impacts. The remainder of this presentation showcases a handful of successful Complete Streets projects in the Northeast Florida area. Note the different contexts of the projects, showing how a complete street is different for different area types. The first example shows US 17, Main Street in Jacksonville. Prior to this project, the roadway featured wide lanes, no median, and basic sidewalks. The project reduced lane widths to provide space for a landscaped median and introduced street trees, enhanced crosswalks, and other features to manage speeds, improve safety, and make the roadway more accommodating for pedestrians. In this more suburban example along Archer Road in Gainesville, we see how lane widths were reduced to provide for bicycle lanes. The example also shows the introduction of a mid-block crosswalk to improve pedestrian connectivity. Finally, in this rural example along State Road 207 in East Palatka, a shared-use path has been constructed in the right-of-way of a rural highway. While the design and operation of the roadway are left unchanged for motorists, the new path provides for the safe mobility of cyclists and pedestrians along the road. This concludes the Community Traffic Safety Program presentation on Complete Streets.